screen. Hope everyone can see my screen. So this was a figure that we were discussing yesterday. So a building will be divided into three parts. What are the substructure, plinth or basement, and superstructure? And we just had a quick look at how the loads are being transferred to everyone. We know um, here, since this is a load-bearing wall, the load from the slab will be transferred to the wall, and finally it will be distributed to the foundation. So as the as we go move from top to down, the load value will be cumulatively increased, and hence what will happen as we move down, the size of the components will also increase accordingly. So all these things we have discussed in the previous class. So about foundation, we had a quick look at foundation, floor, until where we have finished foundation, plinth, floor. So we have discussed that what are the main function of a floor. We'll just look into that again. The main function of a floor is to provide support for occupants, furniture, and the equipment of a building, to divide the building into different levels for creating more accommodation within the limited space. All the floors, whether basement, ground, or upper, should be strong enough to support the floor covering and other superimposed loads. The floors provide a clean, smooth, impervious, durable, and wear-resisting surface, should have adequate fire resistance and sufficient heat and sound insulation. So if we go into detail into this each point, the first point tells us that the main function of a floor to provide support for occupants, furniture, and equipment of a building. So what will happen if there is not a we haven't provided a proper floor? If we are just resting on an earthen surface, we cannot support our furnitures properly into that earthen surface. That's why we are compacting the earth below it, and we are providing a hard surface above that, so that it can support all the loads coming on it. So that's the main function of a floor. And next function is to divide the building into different levels to accommodate more people. That means this type of construction is not a vertical construction. As we all know, rather than growing horizontally, horizontal development will always require more land, more piece of land. But if we are going to construct an apartment where we can accommodate a lot of families in a single space, so we can avoid the wastage of land. So with floors, we are dividing each levels. The floor will be the thing which divides each levels. Then all the floors, whether basement, ground, or upper, should be strong enough to support the floor covering and other superimposed load. What are the superimposed loads that can come onto the floor? All the loads from the furniture, if there's some machinery or all those things will come onto the floor. The floors provide a clean, smooth, impervious, durable, and wear-resisting surface. So this is very important. It should be clean, smooth, impervious, durable, and wear-resisting. So what will happen if we construct a floor and that is too slippery? That's a functional error. That means this floor should not be so slippery that people should not fall by slipping. So we need to take care of all those things. The floor finish that we provide should not be too slippery, and it should be clean. It should be we should be able to clean that very easily, and it should be impervious. Impervious means it should not allow any liquids or any other water materials to impregnate into that floor surface. So our floor should be impermeable, and it should be durable and water resistant. It should have sufficient fire resistance and sufficient heat and sound insulation. So suppose a fire hazard happens, basic thing is we need to rush out the occupants out of the building. So at that time, a floor should be strong enough that it should not be affected by fire. The main problem with wooden floors is that once a fire happens, it will be very difficult for the occupants to move out. So that's why nowadays no one is using wooden floors. If we look into our old buildings, most of the floors would be wooden, especially if it's in a second story or third story. The floors would be made out of wood, but that's too dangerous in case of a fire hazard. So our next part of the building, what we are going to discuss is about walls. So the main function of walls is to divide the space into different rooms. We all know how walls are dividing our space into different rooms as per our convenience. The walls support the loads from the roof or upper floors to the foundation. That we have discussed how a load-bearing wall distributes the load from the above to the foundation. So piers or pillars, pillars are thickened sections of walls placed at intervals to carry the concentrated loads. Suppose a concentrated load happens, we'll provide a pillar or a pier so that wherever a concentrated load happens, it can be easily distributed. So it should be stable against overturning by lateral forces. That means if someone is leaning onto the wall, it should not overturn by that force. And next thing is the main lateral force that comes into play while we are constructing a building is the wind force. So our wall should be strong against wind. It should not overturn due to the effect of wind. So that wind is also a lateral force. The external wall should provide sufficient resistance against weather agencies like sun, wind, rain, and snow. Wall should have sufficient heat and sound insulation because it's necessary to maintain a proper livable environment inside our space. So it should have proper sound and heat insulation. The noise from outside should not reach the inner part, and also if it's a hot arid region, the heat should not come inside. Privacy and security against burglary and theft. So these are the functions of walls. So main function we might tell that it is to divide a space, and in many of our cases, for small buildings, the walls will be constructed as a load-bearing surface, load-bearing walls, and for very large buildings, we will not provide walls as load-bearing structures. We will just provide walls as dividing, just to divide our space. So the loads will be carried by the pillars or columns or piers. So you need to understand that in nowadays in construction we are not anymore providing walls as a load-bearing structure, because if you provide walls as a load-bearing structure, it may not be stable against earthquake load. So once the earthquake happens, what will happen is that since the walls are not reinforced, that means since we are not providing steel bars inside the walls, when an earthquake happens, our roof, suppose the roof is concrete, so it will be a concentrated mass above our walls. So that mass will move. The reaction will be different, because since the wall is mainly made up of brick, while the roof will be reinforced concrete. So the reaction of these two parts against earthquake or wind may be different. So the lateral movement will also be different, and that can cause a load unequal distribution, and which will lead to the collapse of the building. So instead, if we are using columns or pillars, both the columns and the our roof or roof slab might be concrete. So the reaction of these two elements, we can interconnect that using steel bars, and the reaction of these two parts will be almost similar. And since we have also provided steel bars inside that, it may not cause as much damage as that of a small building in which a load-bearing wall can cause. So in many of the cases, you might have noticed that whenever an earthquake happens, it's always safe for a very large building, and the major casualty will happen to people who are living in small buildings, because in small buildings, what is the reason? In small buildings, the walls will be the structure which will carry the load, and since it is a load bearing walls, So this will lead to a collapse much faster than we think. But for large buildings, the load carrying structures will be beams, columns, and slabs, and they will be interconnected using steel bars, and they will be strong against earthquakes. So it is always safe inside a large building than a small building. If you have noticed the history, we will understand that majority of the casualties happen to those inhabitants inside a small building, because what happens is that once the vertical alignment of the wall is changed, since there's a slight movement horizontally, the vertical alignment will change, and the vertical load carrying capacity of the wall will be altered and will be reduced like anything, and that will lead to a complete collapse of the building. So that's the major issue happening for a non-load bearing walls. So in our place, many of our small houses will be constructed using load bearing walls, and that will be dangerous if something happens like a earthquake happens. So just keep in mind that always it's safe to be inside a large building during an earthquake. So next are doors and windows. So the main function of doors in a building is to serve as a connecting link between the internal parts and to allow free movement to the outside of the building. Windows are generally provided for proper ventilation lighting, and their number should be determined according to the requirements. So as per our building rules, there are some provisions mentioned that windows and doors should be placed uh, at, at, at a specific points, and the numbers and sizes of windows and doors are also mentioned as per the function of that building. Suppose if it's a commercial building, the number of doors and windows to be provided will be different than that of a residential building. So all these things are mentioned in building rules and specifications. So we will have to refer to all those rules and specifications while we are going to design a building. So windows are generally provided for proper ventilation lighting, and their number should be determined according to the requirements. So the proper ventilation and lighting, you understood why it is important to provide proper ventilation lighting to maintain a healthy environment inside our occupancy. It is always necessary to provide proper ventilation and lighting. It should proper ventilation means it should not be like ventilation should not be too high or too low, and also lighting means the outside sunlight should not enter the building. The sunlight should not be too intense inside the building, so it should be maintained within that limit. So if you look at a library, it is always recommended for a library to be in a dark place. Understand? We should not keep our book racks near to windows or doors or open area, because once the sunlight enters our building, and our books can get damaged, our paper can get damaged due to the effect of sunlight. If sunlight is constantly falling onto our book, what will happen to our papers? It might get damaged. So it is always recommended for a library to be in a dark space where outside light is very limited. There should be some light, but it should not fall directly onto the book racks, so that can harm or that can damage our papers. So according to the function of that particular room, the ventilation and lighting should be adjusted. So all these things will be done using doors and windows. And also another thing is that for bathrooms, the size of the doors and windows should not be so large, so that in order to maintain privacy. And for bedrooms and for living rooms, for office spaces, and for factories, for all those buildings, the size of and number of buildings should be different. So these are the main things why we are focusing on windows. Next, they should be strong enough to resist the adverse effect of weather. That means windows and doors should be able to resist the adverse effect of weather. You might have noticed that while during a rainy season, most of our doors will get tight while we are trying to close and open it. So what happens is that during rainy season, doors and windows will be mainly made of out of wood, and wood will absorb moisture from the environment, and this and it can lead to a small increase in the size of our door. So our door might get jammed or stuck during this kind of weather. So it is always recommended that it should it should be strong enough to resist the adverse effect of weather. And if alternate uh, summer and winter are happening, especially in places where there is extreme weather. Extreme weather means during summer the weather will be too hot, and during winter the weather will be too cold. So alternate winter and summer season happens in such areas, and in those areas the specification will be different for doors and windows, because these alternate weather changes can affect windows and doors very badly. Next point, they should be capable of being made airtight to achieve insulation against sound and heat. They should not be affected by white ants and moisture penetration, as this will reduce the strength and durability. They should offer sufficient privacy without inconvenience or trouble, and security against theft. So these are the functions of doors and windows. So you need to understand that wherever we are providing doors and windows, uh, doors and window frames are not designed to carry loads. So wherever there are loads and window frames, we should provide a lintel above that. That is mandatory to provide a lintel above that, because the load above cannot be transferred safely by using a door or window frame. They are not designed to do so. So wherever we are providing a doors and windows, we should provide lintel above this. Lintel means it's a reinforced beam, we can say, a kind of thing where it is reinforced, and what it will do is like it will take the load from the above and it will distribute to the walls. So I'm talking about a normal building where we are using load bearing walls, and if it's not a load bearing walls, it's obviously that we need not provide anything above that. The loads will be transferred by beams and columns. So these are the functions of doors and windows. The next is beam. So what you know about beam? Beam is actually a horizontal structural member which carries floor, slab, or roof. So what happens is like we'll keep our floor slab or roof slab on the beam, and this beam will be connected to columns. Columns means pillars, and these pillars will be connected to our foundation. So beams are the horizontal structural member which carries floor, slab, or roof. So beam slab can be of any material. It can be made up of concrete, reinforced concrete. It can be made up of steel. It can be made up of timber. So anything can be a beam, but beam should be capable to transfer the load to columns or pillars. So there will be a deflection limit for this beam. So we will be designing the beams based upon the deflection and whether it will crack. All those criteria we will check. So there will be a limit for all those deflection. We'll look whether beams can carry this load safely without reaching its maximum deflection limit. Deflection limit means beam will bend downwards. So there will be a limit for that bending. It will be mostly it will be 20 millimeter for a normal beam of normal size, and depending upon the load carried by it, there will be a difference in, and also the members what we are using as a beam, there will be difference in this value, but it will be around 20 mm generally. So if the deflection or the bending is more than 20 mm, we will have to change the size of the beam. So these beams are the things which will carry loads from roof or wall, roof or floors, and it will distribute it to columns or pillars. And next is lintel. Lintel is a beam that supports the masonry work over openings in the walls. So as I told earlier, wherever there is an opening, that means wherever we are providing an opening for windows or ventilation or doors, we should provide lintel above that. So it's a beam what we are providing over the openings on the walls. So if can I ask anyone what's the difference between beams and lintels? Arsha, Anil,
Yes, sir.
uh, can you please explain what's the difference between beams and lintels?
A beam is a horizontal structural memory where lintel support the work over openings in the wall.
I hope you haven't understood it clearly. Have you seen a lintel and beam? Or have you ever had a visit to any construction site?
No.
So this beams are mainly used wherever there. Have you understood what's the difference between a load bearing wall and a non-load bearing wall?
Yes, sir.
Okay, so these lintels are mainly used in load bearing walls. A typical example will be around will be our residential building construction, like our home. So whenever we provide an opening for doors or windows, we should keep something to support whatever comes above that opening. So that thing, member is known as a lintel, and beam is actually provided for non-load bearing walls, where the load from the above, the floor load from the above or the roof load from the above, will be transferred to the beam, and this beam will transfer the wall load. So uh, that's the main difference between beams and lintels. Hope you understood.
Yes.
Okay, next is sunshade. So if I can find some figure to properly explain you, um, to be better. So in our figure, you see this. This is a lintel. Understand? So since there's a door, we'll provide a lintel above the door. If there is no door, it's not necessary to provide a lintel, but it is always recommended to provide a lintel throughout uh, the same height throughout the length of the wall. But since there is a door here, it is mandatory to provide a lintel above it, because this brick masonry, the load from the brick masonry uh, won't be safely distributed over the door frame. So the door frames might be weak. So that's why we are providing a lintel above this door frame. So it's mandatory to provide a lintel wherever there is an opening for a door or a window or something. And also in most of the cases, we will provide a lintel throughout the length of the wall for making it more safe. And next is sunshade. So sunshade is a projection provided outside a building above the doors and windows to prevent direct sunlight and rain to the room. You all know, you might be familiar with sunshade. So the main function is to prevent direct sunlight and rains to the room. So it's always better to allow scattered sunlight to enter a room instead of direct sunlight. So direct sunlight can harm many of our furniture, floor, or painting, books. So it's not recommended to allow direct sunlight inside a home, while we can allow scattered sunlight. And from in our figure, this is the sunshade. Hope you understood. Which will be cast. This lintel and sunshade will be cast as a single member in most of the cases. So wherever there's a door or windows, we'll provide a sunshade above that. So the rain and sunlight won't come directly inside our home. And next is parapet. So parapet is a short masonry wall built on top of the roof of a building. It's called parapet. So as an enclosure above the roof, as an element for good appearance. So main function is to provide an aesthetic appearance for our building. And what will be a parapet? If this is a roof, and along the boundary of our roof slab, we'll provide a small parapet. The height mainly, mostly the height will be around 1.1 meter or 1 meter or even below that. So the main function is to provide as a secure as a safety measure so that no one will fall from the roof easily. And also in most of the cases you can also provide it as a element for good appearance, so improving the appearance and the aesthetic appearance of our building. This is parapet. This will be also mostly masonry, and since it does not carry much load above it, we will use lightweight bricks or even like ornamental works into that. It just functions as a safety measure and also as an aesthetic material. So this is a parapet. So this is next is weathering course. This is the layer provided over the roof slab to protect the roof from weathering agents like sunlight, rain, and wind. So weathering course where we'll provide above the roof slab. So have you heard about Dr. Fix-It and other materials? So what we'll do is like once we have cast our roof slab using concrete, we'll provide a weathering course above that. So it will be something around 2.5 or 3 centimeter thick. We will mix this Dr. Fix-It or any other chemicals or any water retaining or water repelling agents. Some chemicals will be available in the market. We'll mix that in water and we will mix cement and sand along with it, and we will apply on the surface of our roof. So what happens is like our RCC won't get affected. RCC means reinforced cement concrete slab won't get affected by sunlight or wind or rain. So that's why we are providing a weathering course as a security, as a like just like we provide a tempered glass for our mobile phones screens. We'll provide a weathering course for our roof slab. So next is roof. It is the uppermost part of the building whose main function is to enclose the space and to protect it from the effects of weather elements. The roof structure should be strong and stable enough to take the anticipated load safely. So the main function, to provide protection from the effects of weather elements and also to provide an enclosed space. And the main the roof structure should be strong and stable enough to take up the anticipated loads. So while we are constructing, we are providing a roof, we will anticipate what are the loads that may act on the roof. Mostly the loads will be due to the weather elements like wind or rain. So our roof should be able to handle all those loads safely. And in many of cases where there is accessible roofs like an RCC roof, we will also look into the maximum load that might happen on that. Suppose if you provide an access to that roof, people can climb onto that, and some other animals might also come onto that, and we might also have to give some storage spaces above that. So all those loads will be calculated while we are designing the roof, and it should be stable enough to carry all those loads. The roof covering should have adequate resistance to resist the effect of weather elements that we have discussed. The roof should provide adequate insulation against heat. The roof should have adequate insulation against sound from external sources. Should offer an adequate degree of fire resistance. So these are the functions of roof. I don't think there is need for more explanation to this. And next is the steps and stairs. So why are we providing steps? Steps are provided for the access to the building. Where are steps provided? See, this is a step provided because our floor will be always kept high from our ground level. I hope why a floor you might have I hope you might know why we are providing a floor at a height from the ground level. So in order to access that floor from the ground level, we'll be providing steps. So while defining these steps, there are also some specifications that need to be followed. So it will be different for different buildings. For a public building, the height of each step, that's known as rise of a step, that should be maintained within a limit. Otherwise, what will happen? Uh, for a public building, there will be a different different people, different kind of people will be trying to access those steps, and the height of each step should be kept within the limit. Otherwise, it will be too difficult for them to climb those steps. So there will be people having good health. They can access, or they can climb the steps very easily. While those old age people, it will be difficult for them to climb that easily. So the height of each step should be maintained within the limit, and in most of the cases, the height of each step will be kept as 15 centimeter. So that's the optimum size of a step. And what are steps are provided for the access to the building, and the stair is a structure consisting of a number of steps leading from one floor to another. You might know what's a stair. So location of all stairs in all types of residential public buildings should be such that afford the easiest and quickest service possible to the building. So uh, the location of the stair is very important in a building. So it should not be kept in such a place where people have to walk to that place and then climb those stairs up and then reach the destination. It should be easily accessible to everyone. And as I said earlier, the height of each step should be maintained within the limit so that everyone can climb that steps for a public building. While if it's a private building or a residential building, we can have a small adjustments in that level, because as the number of as the height of the each step reduces, the number of steps will increase, and that can lead to more cost. That's why in private properties, we'll keep the height of the steps maximum. It might be around 22 centimeter height of each step, while for public buildings where different age groups will try to access that steps or stairs, the height of each step will be kept below, not below, around 15 centimeter. So the location is also important. It should be easily accessible to everyone. So it should be easy, and it should be the quickest way to reach the different levels. That's why location of stairs is important. So this is a means of communication between various floors. It also acts as an escape from upper floors in the event of fire. So whenever a fire happens, it is strictly prohibited to use a lift for the rescue service. So whenever a fire happens, the only thing which will be left for everyone to reach outside the building is the steps, the stairs. We should only use stairs while a fire is happening, and at that in that case, the accessibility of the stairs should also is very important. That means always will provide a fire stairs outside the building, so that everyone can run easily from their space to the outside of the building, and they can climb the stairs down. So that's the thing. It also acts as a escape route whenever a fire hazard happens. Next are the wall finishes. The finishes of walls are pointing, plastering, painting, and distemper, etc. So, what is meant by pointing? So, pointing is something whenever we use a brick masonry. Brick masonry എന്ന് പറഞ്ഞാൽ മനസ്സിലായി, അതായത് നമ്മൾ ഇഷ്ടിക കൊണ്ട് കെട്ടില്ലേ, നമ്മൾ സാധാ ബ്രിക്സ് കൊണ്ട് വാൾസ് കെട്ടുന്നതിനാണ് മേസൺറി എന്ന് പറയുന്നത്, ബ്രിക്ക് മേസൺറി. ആൻഡ് വി വിൽ പോയിന്റ് ഔട്ട് each of the border of each brick using cement mortar. Cement and sand, we will mix cement and sand in a particular proportion, and we will point out the outer surface of each brick. So that's known as pointing. Next is plastering. Plastering means എന്താണ് tape. We will do the same. We will mix cement and sand in required proportion using water, and we will paste it on the surface of brick masonry, and that's known as plastering. And next, painting and distempering. Painting, we'll use paint on plastered surface, and also distempering, the same thing. So distempering mainly what happens is like we will get in the form of a powder, and then we will mix it with water and we will apply. While painting, we'll get the paint in the form of liquid. So these are the different wall finishes: pointing, plastering, painting, and distempering. Pointing means you might have seen in some cases where we will point out the gaps between bricks using the cement mortar. Cement mortar means cement and sand mixture. So that's known as pointing. Next is plastering, as I said, done tape എന്ന് പറയും. Next is painting, distempering, etc. So this is the first point regarding wall finishes. Next, these finishes protect walls from effects of weather. So in many cases, what happens is like if we are just leaving it as a brick masonry without applying any plastering or pointing works, as time goes by, it might get degraded due to the effect of weather, due to the all the alternate summer and winter seasons or rainy seasons. The brick masonry might get degraded. That's why we are providing plastering and other finishes in order to protect our walls from degrading. And also, it's necessary that to provide a better living environment. You might have noticed that whenever a wall is properly plastered and painted, the dust will be reduced when compared with a non-plastered wall surface. So, and also the fungus and other microorganisms growth will also be reduced whenever we provide proper finishing to our walls. So it's always necessary to provide plastering and other finishing works to give a proper living environment. So these finishes protect walls from effects of weather. It covers the defective materials or poor workmanship to some extent. So whenever something happens to the defective materials, we can cover that easily with these wall finishes, and improves the aesthetic appearance of the building. As you all know, it is always good to see a finished wall surface and an unfinished wall surface. So these are the things, and so we were discussing about the different parts of a building, components of a residential building, and we have discussed about foundation, concrete foundation, basement, steps, flooring, floor finish, damp proof causing, doors and windows, lintel, sunshade, brick masonry, roof slab, weathering goes to the roof slab, parapet, and other finishes. So we have discussed about it all, and I hope everyone have understood what are the different parts of a building and what are the terminologies used to describe the different parts of the buildings. Does anyone have any doubt regarding the same? Albert, Tom, George,
Yes, sir.
do you have any doubt regarding?
No, sir, no doubt.
Okay, so it's a very simple topic. So we have just discussed what are the technical terms for different parts of the buildings. So next we are going to discuss about the building areas. So there are different names for different type of areas to be mentioned for a building. So we are going to discuss about the different areas. So plinth area. Plinth area means the area of the building at the plinth level. Does not include the area of open porch, uncovered staircase, and like. That means whenever we tell someone about what is your plinth area of a building, you might have heard many people telling that the plinth area for a building is 1,200 square feet, or the floor area of a building is 1,000 square feet. So you might have heard people telling that those things. So we are going to discuss about building areas, and the first thing we are going to discuss is about plinth area. So actually, plinth area means the area of the building at the plinth level which does not include the area of open porch. So you might know what is meant by plinth level. So at this level, plinth level, we'll find out the area of a building. That means we'll include all those covered areas. We won't include uncovered areas like porch, etc. So see, it does not include the area of open porch since it is not enclosed by wall, and uncovered staircase and all those things. So if our stair is uncovered, we will include that, especially if our staircase is inside our building, we will include that in the plinth area. But if the staircase is provided outside the building, we won't include that in plinth area. So plinth area does not include the area of open porch, but open porch and other open structures. At the plinth level, we'll draw a plan and we will find out what are all the things which are enclosed. We will take all those things as the plinth area. And next is built-up area. So built-up area means the covered area at any floor covered by a roof other than cornice, roof, or weather shades permissible. So built-up area means the covered area at any floor covered by a roof other than cornice. So if you are going to describe a place where we have an open area inside our home, that means that in all buildings, what we call a nalugattu, we'll be having an open area inside the building. So we won't take that as a built-up area since we haven't constructed anything in that area. And also this applies to you might have seen in buildings where the two-story residential buildings where the ground floor will be completely covered while the first floor might not be built up completely. We'll leave some spaces as an open terrace. So that means that open terrace won't be taken as built up area. We will take those areas only where we have built something. We won't take the open areas. And the floor area means built up area of a building at any floor level. So we'll describe by each floor area. That means floor area of first floor means the built up area of first floor. Floor area of second floor means the built up area of second floor. It's like that. And the floor area ratio, FAR, means the quotient obtained by dividing the total floor area on all floors by the area of the plot. Suppose our area of the plot is maybe 4 cent or 5 cent. 1 cent means nearly 40 meters square. It will come around to 40 meters square is 1 cent, and our total area might be 100 meters square, and our total floor area might be 60 meters square. That means we'll add all the floor areas of each floor, and suppose we have a 3-story building and each floor has a floor area of 20 meters square. The total floor area will come to 60 meters square, and we will divide that by the total area of the plot. The total area of a plot means the land where we are building, So the total area of the plot might be 100 meters square, while the total floor area of our building will be 60 meters square. So we will divide 60 by 100, and our floor area ratio will be 0.6. That's known as 0.6. Floor area ratio, it's the total floor area of all floors divided by plot area. So this is regarding all those things. And if you have any doubt regarding any of the parts of the building or anything that we have discussed as of now, you can ask. So can I call anyone from you yourself? Is Amal Binoy here? Amal Binoy? Amal Binoy? Alina Gigi.
Yes, sir.
So could you please explain what you have understood by foundation concrete?
Um, Foundation. Okay, sir. Foundation is the uh, mm,
Just
it
explain
ensure.
in your own words.
Okay, foundation ensure the stability of the structure. That means it maintain the wall, uh, the wall part of the building uh, mainly. Mm, okay, then it ensure the stability of the building against all the uh, um,
My question is like why we are providing a foundation concrete here, not regarding what's meant by foundation. Um, why we are providing a foundation concrete,
foundation.
the bottommost part.
I don't know properly, sir.
So foundation concrete is provided in order to give a uniform surface for a building. So since it may not be easily available, suppose we are making a trench, and it might not be a smooth surface for a building to start a construction, and it is necessary to provide a smooth surface. We are providing foundation concrete, and also it distributes the load uh, equally onto the soil below. So that's why we are providing a foundation concrete. Mostly it will be unreinforced concrete. That means we won't use any steel bars for foundation concrete for small buildings. But if it's a large structure like a crane foundation or a very large building foundation, obviously we might have to give steel bars also. So this is basically a foundation concrete. So next, um, okay, thank you, Elena. I'll call someone else. Is Aniranj present? Is Aniranj present? Aniranj? Okay. Is Angel Thomas here? Angel Thomas? Am I audible first of all? Can anyone respond whether I'm audible?
You're audible, sir.
Okay. Um, Austin, since you have responded, let me ask you.
Yes, sir.
Okay. So what you have understood by the term foundation? What are the different materials that we can use to construct foundation?
Foundation is the base which comes above uh, the the base of the building. It supports. It provides support to the walls and the beams as it helps to stabilize the structure over the foundation concrete, and the materials used in making foundation concrete are usually cement and rocks.
What if we use brick masonry?
I
Can we
don't know,
use
sir.
brick masonry? Yeah. So we can also use brick masonry. It need not be necessarily stone masonry. We
Okay,
can
sir.
use brick masonry also. It can also use reinforced concrete, but
Okay,
it
sir.
will mainly depend upon the economy of our construction, the cost of construction.
Okay, sir.
So why, Austin, there are different breadths for a foundation? Why the width of a foundation increases as we move from top to bottom?
The width of the foundation increases as to increase the surface area so that the weight of the structure is evenly distributed below the foundation concrete.
Okay, good, Austin. Thank you. So, whom shall I ask next? Can anyone voluntarily come forward? Dalvin Jones. Is Dalvin Jones here? Dalvin Jones. So I think it's better to cut the attendance of the students who are not responding to my call. Ibn Devas here. Ibn Devas here. Anjita Nambiar. Anyone, could you please respond? Anjita Nambiar. Am I not audible?
You are, sir.
Why are the students not responding? So can anyone come forward voluntarily? Or else I think it's better to stop the class here right now so that you can. Yeah, I think it's better to stop the class right now since no one is responding. So thank you all.
Sir, sir, I have a doubt.
Yeah. That's,
Is distempering whitewashing?
it's not same. December is actually we noticed it will be a different. Whitewashing is just we'll get a mixture of some chemicals and we'll mix it with water and we'll apply. Distemper is quite different than whitewashing. They may have you noticed some government buildings where it will be painted in a kind of yellowish paint. Have you noticed?
Oh no, sir.
Okay, so there are in most of the government buildings, what they used to do earlier was like they will paint it, they will distemper it using a yellowish kind of paint. So that's
Oh,
actually a
okay.
distemper. It's the process is almost the same like whitewashing, but the powder that we are using is quite different.
Oh, okay. Thank you, sir.
Okay. Anyone has any doubt?
So I had one.
Yeah.
Sir, in flood-prone areas, do we use foundation concrete like in the Ganga basin and all, where it floods very heavily? Do we use the foundation concrete there too?
In some cases, we can use, but when there is actually if it is flooded like anything, especially if we have a Kutanad region, what we do is like we'll keep the foundation depth very large, very we'll keep our foundation depth large so that it won't affect our building. So that's what we basically do. And in some cases, what nowadays what's happening is like we'll provide elevator surfaces. That means we'll place some pillars and we will build our building over that, so that even if floods happen, it won't affect uh, our uh, our floors. The main objective is that the moisture should not reach the floor or the brick masonry. Once the moisture reaches the brick masonry, that ends our walls, it can lead to loss of strength and it might collapse.
സാർ ആ ചാറ്റ് ബോക്സ് ഒന്ന് നോക്കോ? അശ്വിൻ ഒരു ക്വസ്റ്റ്യൻ ചോദിച്ചിട്ടുണ്ട്.
1 minute. Ashwin. Turpentine and thinner. So the turpentine and thinner basically, you might have noticed some polish. Understand? So we'll add this turpentine to the polish, just like we add water to a polish to make it of different thickness. That's why we are using turpentine. But nowadays, have you seen this a new advertisement about sheen lac polish, where we can add water to make it thin? So before that, there was no provision to add water. So the only option was to provide turpentine to mix it with our polish and other things, so that it will make a thinner coat. So it will be too thick that what we get from the market. So depending upon our quality of polishing, what we require, we will mix it with turpentine and other thinners, and we will apply that polish. Who asked that question? Chandana Rajiv. Who asked that question?
So it was Ashwin.
Ashwin. Hope Ashwin got the answer. Could you? Okay. So that's why we are using turpentine. But the advertisements that have released a few months ago regarding the sheen lac polishes, where it is seen that they are mixing it with water. So who asked that? What's the minimum thickness of foundation concrete? Basically, we'll provide foundation concrete of maybe 10 centimeter thick foundation. So this is a normal procedure what we follow. It will be normally about 10 centimeter thick. What do you mean by foundation footing? Sahan, are you asking about the difference between foundation and footing? Sahan,
No, sir, it's about foundation footing only, not difference.
Foundation footing means like foundation is actually a general term for the support of the building, but footing means it's actually individual. Footings are provided basically wherever there are pillars or columns, and below that we'll provide individual footings. And for foundation, we'll call it as a general term. Both are same in the sense, but technically the difference is that foundation is actually a general term used for all those structures which will help us to keep our structure intact, while footing will be a specific term for the particular structure. Understood? Where we will keep a footing below a wall or a pillar, below a pillar, that will be known as a footing, while foundation is actually a general term. Foundation footing, it should be the same. So anyone has any other doubt? Plinth level. Okay, I'll explain it with the figure. So I hope you can see the figure regarding the plinth. See, plinth is a point where our foundation and our basement and our walls will meet. That means the point at which we will start to construct our walls. That's known as plinth. So at that level, that level is known as plinth. That means if suppose we are going to construct our wall at a height of 0.6 meter or 60 centimeter from the ground level, our plinth level will be 0.6 meter from the ground level. So that level means that the height from ground at which we will start to construct our walls. That's known as the plinth level. Who was the person who asked that question? Alan Cruz.
Sorry.
Did you understand?
Sir, Alan Thomas. Yes, sir. Yes, sir.
Okay. So the point at which, the level at which we'll start to construct our walls. So anyone with any other doubts?
Sir, what is build-up areas?
Built-up area, not build-up area. It's built-up area. So if we
Built-up area.
see, I'll explain it starting with plinth area. So plinth area is basically at the plinth level, we'll take all the areas enclosed by that. But built-up area is different when it will not be necessary that the wall structure. That means, have you seen some buildings where there will be openings inside the building? That means there will be some open surfaces or open playgrounds or open like courtyards inside the building. Those areas won't be counted as a built-up area. Understood? That's not enclosed. Understand? In plinth area, the only things what we skip are those car porches and staircases that are built outside the building. And in built-up area, we'll take all those places where we are utilizing that that area, that we have built something on that. As I explained earlier, you might have noticed in some buildings, some houses, where the ground level will be fully constructed, while the first floor there will be some open terrace. Understand? So when we take the built-up area, what should be the built-up area of open? We won't consider the open terrace. We'll just consider those area where we have constructed something, where built up something. That's known as built-up area. See, the definition means the covered area at any floor. It should be covered. Be covered by a roof other than cornice. Cornice means you might be difficult for you to explain. The cornice is actually an ornamental work projected from the roof slab. So it's built-up area should be a covered area. So that's why I have told you that if we take the example for a Naligat, what happens in Naligat in the center part there will be nothing built up. So that area we can skip when we calculate the built up area. Similarly, for an open terrace, there's nothing above. There's no cover above that. It's not covered. It's open. So that's a built up area. Understood? Who was the person? Who asked that question?
Pruthvin, sir.
Okay. Understood, Pruthvin?
Yes, sir.
Okay.
Yes.
Anyone with any other doubts?
സാറേ
സാധാരണ ഒരു വീടിന്റെ എത്ര ഏരിയ ഒക്കെ എത്രയാന്ന് ചോദിക്കുമ്പം സ്ക്വയർ ഫീറ്റ് എത്രയാന്നല്ലേ ചോദിക്കുന്നത്. അത് ബേസിക്കലി പ്ലിന്ത് ഏരിയ ആണ് ഉദ്ദേശിക്കുന്നവര്.
അതെ, പ്ലിന്ത് ഏരിയ. അതായത് നമ്മൾ ഔട്ടർ ടു ഔട്ടർ സർഫസ് ആണ് എടുക്കുക, മനസ്സിലായോ?
ഓക്കെ സർ, താങ്ക് യു.
അതായത് നമ്മൾ തറ ലെവലില്ലേ, അതാണ് നമ്മൾ ശരിക്കും സ്ക്വയർ ഫീറ്റ് എടുക്കുക, മനസ്സിലായോ? അതാണ് നമ്മൾ പ്ലിന്ത് ഏരിയ എന്ന് പറയുന്നത്. നെക്സ്റ്റ് സഹാൻ സക്കറിയ, വാട്ട് വാസ് ദി നോർമൽ ഹൈറ്റ് വിത്ത് ദി സ്റ്റെപ്സ് ഷുഡ് ബി കൺസ്ട്രക്റ്റഡ്. അപ്പൊ ഇതൊരു പബ്ലിക് ബിൽഡിംഗ് ആണെങ്കിൽ അത് ലിമിറ്റ് ചെയ്തിരിക്കുന്ന ഒരു 15 സെന്റിമീറ്റർ ആയിരിക്കും ഓരോ സ്റ്റെപ്പിന്റെ ഹൈറ്റ്. അതായത് ആളുകൾക്ക് എളുപ്പത്തിൽ കയറി പോകാൻ വേണ്ടിയിട്ട്, പല ഏജ് ഗ്രൂപ്പിലുള്ള ആളുകൾ ഉണ്ടാവും, എല്ലാവർക്കും കോമൺ ആയിട്ട് കയറി പോകാൻ വേണ്ടിയിട്ട്. So as the size of each steps increases, what happens is like it will be difficult for us to climb, but it will be economical for us to construct those steps, but it will be difficult for us to climb. We can keep the height of each step like around 20 or 22 centimeters. That will reduce the number of steps to be taken, and also our cost of construction, but that will make climbing the steps difficult. So the recommended value is 15 centimeter. That should be the comfortable height where everyone can climb that steps easily. Chandra, I've already shared these slides in the classroom. So how can we make a roof without weathering? Weathering, Sean, could you please? Sean Shaji?
Yes, sir.
Okay, actually, what did you mean by this question? How
Roof, that's not happening, weathering. Preventing it from...
Not to prevent weathering. Are you asking about weathering?
Yes.
So if it's an RCC or concrete roof, it sure 100% sure that in our climate it will be subjected to weathering at some point of time. So when there are continuous rainfalls, there might be cases that water can penetrate inside our roof, and it can corrode our steel bars that we have provided inside the roof concrete. So that will lead to further cracking, and at some point it might lead to collapse. So weathering is actually unavoidable. The only thing we can do is maybe we can provide some weathering cores, to protect that roof from further weathering. You might have noticed nowadays in any of the concrete structures constructed, we'll use a weathering course above our concrete, so that the normal action of weather, it won't get corroded easily. So it's difficult to construct an concrete building without weathering, but only thing we can do is like we can prevent it by using some weathering courses. So Zakaria, what is the reason behind making the floor mixed with cow dung before 20th century? I don't know. So I really don't know why we are mixing cow dung. Might be there might be some fiber inside cow dung. It might increase the strength in somehow. There are some research that might have happened regarding adding some materials to concrete. Instead of normal concrete, we'll add some materials like fibers or something else. So this cow dung, actually what happens is like when this dried cow dung, it will have fibers in it. So these fibers will improve the strength of concrete. So that might be the reason people might have used that earlier. Still some researches are going on, but I don't know how it will be economical to add cow dung into it.
Okay, sir.
So anyone left with any other questions? Parapet, how is ornamental? Is false ceiling? Parapet, Chandana. Yeah, parapet, have you seen instead of brick walls, we'll provide some precast concrete ornamental works for parapet walls. Have you seen in some buildings? We can also provide some steel ornamental works or something like that for parapet. Have you seen that? The main objective of parapet is to provide a safety measure for occupants who are supposed to take the who are supposed to access the roof. And the false ceiling is something which is provided for decoration, where we'll provide a ceiling which is made up of some other materials, not to cover the top part, and we will run all our electrical and plumbing and all other things inside that, and we will cover it using false ceiling. It's also used nowadays as a decorative item, where we can provide some light in this false ceiling and all those stuff. So false ceiling is provided below a ceiling. Chandana, I think I have answered your question, Chandana. So the questions asked were like parapet, how it is ornamental, and what is. It's not false ceiling, okay? Parapet is not false ceiling. False ceiling is provided below our ceiling. Nowadays, the main material what we use for ceiling is like there'll be some boards available. Gypsum boards will be available. Those are the main material what we are using. We will be providing false ceiling. Parapet on the other end, it is actually provided on the outer edge, along the outer edge of our roof slab. You have to provide a protection for the people who are accessing the roof slab. So I hope we can conclude today's class. There was earthing available in homes created for 100 years. Because there was no earthing means electrical earthing. Sahan Zakaria.
Yes, yes.
Because there was no electricity before 100 years in most of our homes. I don't think there will be earthing provided. Actually, it is recommended to change the earthing at every 5 years, but no one does that. If we change our earthing every 5 years, it will be more safe against hazards due to some circuit breaks or all those things. But before 100 years, I don't think so. Buildings had things, because very few buildings even had electricity. But once electricity connection is given to that building, it is necessary and it's mandatory to give an earthing connection. So I think what it will do is like it will redirect the extra current flow or unwanted current flow to the earth. But if there's there is some damage happen to this earthing, automatically it will lead to over current flow, and our bill will increase. Electricity bill will increase. So whenever there is an electrical connection, there should be earthing given, and it is highly recommended to change the earthing at every 5 years. You might have learned about earthing in your 10th standard physics, I hope, where we will provide charcoal or sand, all other things to earthing. Zahan, I hope you have got the answer. So okay, I think it's time to conclude our session. So thank you all.
Thank you, sir.
The material have been posted in our Google Classroom. I think there are still some left to join the Google Classroom. Please tell them to join.
സാർ ഞാൻ കുറച്ച് ലേറ്റ് ആയി ക്ലാസ്സിൽ കയറി അറ്റൻഡൻസ് എടുത്തിട്ടില്ല.
പ്രണവ് അല്ലേ? പ്രണവ്
അതെ
full name പറ.
പ്രണവ് സുനേഷ്.
Okay, I'll mark your attendance.
Okay, sir.
Okay.
Thank you, sir.